Good morning, everyone. Myself Apurva Rajkumar, and here I am with my third project, which deals with defining scalar and vector fields, a tensor, and computing a vector resulting from the product of the initial vector and a tensor T. So the body chosen is a lamp in which the cone or the first body part is a cone which acts as the light emitting part. The second is a cylinder which acts as a holder, and the third is also a cylinder which acts as a base. So this is my definition of a scalar field, and this is the actual result when inputting this definition in the MATLAB code. This is my definition of a vector field, and this is basically a 3-degree polynomial, and it appears to be bulging around the centroid of the second body, and this is the vector field as a displacement field. So here we can observe the displacement of each and every individual points. This is my definition of the tensor T, which is a symmetric matrix, and here is the tensor field. So each and every so the tensor field represents tensors at each and every grid points. So these small crosses, this is the major x-axis, y-axis, and z-axis. This is my MATLAB code. Here we start with uh, the definition of some parameters. We define the first body part, we define the second body part, and we define the third body part as we already did in our second project. This is the actual definition of my scalar field, my vector field, and my tensor field. And here we take the input of the point which we want to transform from the user itself, and then we create vector u and tensor t using those coordinates. So this is my final result. Uh, Here we have the volume of my body. We input the point. Uh, then we create the vector u by inputting these points in the equation. Similarly, we get the tensor t as well, and we simply multiply. We do a matrix multiplication to find the final vector. I have also cross-verified using the same coordinates. I input this point in the original definition of my vector field here and my tensor t. Here I calculated the vector u and the tensor t, and this uh, this is then multiplied. Then we perform a matrix multiplication between our tensor t and vector u, and we finally get the final value, and we can observe that the value received is almost the same. Thus we can conclude that the MATLAB code works perfectly fine. Thank you.